everyone, and welcome back to another episode of Research Done Right. In today's lesson, Lesson 10, we're going to talk about complex experimental designs. Up to this point, most of the experiment designs that we talked about had a minimum of 2 levels. So we know that whenever we're looking for a relationship between an independent variable and a dependent variable, we always have to have some type of comparison group. The minimum number of groups we need to have for a comparison is 2. Typically, you have the control group and you have the experimental group. Also, in all of our cases, we were talking about the use of 1 independent variable and 1 dependent variable. In other words, we were looking to test the effects of 1 manipulation on the measurement or behavior of another. But what happens if you feel like there is more than 1 factor that could be affecting your dependent variable? Perhaps there's more than 1 thing that can affect our behavior or our emotions or our thoughts. And so basically any type of research question has its own corresponding experimental design. So we're going to talk about complex experimental designs in which you have more than 1 independent variable. So we'll start by talking about factorial designs. Another word for a factor is a variable. So anytime you introduce more than 1 independent variable into your study, you have a factorial design. However, along with that additional independent variable, you also have additional possible effects that you could see. So we'll talk about the difference between main effects and interaction effects. Then we'll talk about non-manipulated variables. So we know that the independent variable is something that is manipulated or controlled by the researcher, right? It is our treatment effect. But there are certain variables that are researchers that we don't have control over, that we can't manipulate. So we'll talk about those in the non-manipulated variable section. The last thing we'll do is we'll wrap up their discussion by talking about the assignment of participants. So I know what you're thinking, we just talked about that in our previous lecture, and that's true. We talk about participant assignment a lot, and we also stress a lot the fact that our assignment and selection should be random, right, to account for a lot of individual differences and to maintain experimental control. So we'll talk about assignment of participants in this case corresponding specifically to factorial designs. So the first thing we'll talk about are basic factorial designs. Now, if you increase the number of independent variables you have in your experiment, you are therefore increasing the number of factors, right? The number of things that can influence your dependent variable. So another word for variable is factor. If you have 2 independent variables, you have 2 factors. All the levels of each independent variable are combined with all of the levels of other independent variables. And so the simplest factorial design, if you have only 2 independent variables and each independent variable has 2 levels, we would call this a 2 by 2 factorial design. So basically your first independent variable has 2 levels and your second independent variable has 2 levels. So there are 4 possible combinations of effects on your dependent variable given these 2 independent variables. For example, a researcher is trying to teach her dog to chew her food and not swallow it. She tries giving the dog different sized portions, small, medium, and large, and types of food, wet, dry, or a mix of the 2. So the first question is, how many independent variables are there? How many factors are there? Well, it looks like there are 2. The first factor would be the different size of portions, and that has 3 levels, small, medium, and large. The second independent variable or factor is the type of food that the dog gets, wet food, dry food, or a mixture of the 2. Ultimately, the dependent variable here, right, is how quickly the dog finishes her food, right? And based on that, we can determine whether the dog is chewing the food or swallowing it. Naturally, if someone chews the food, it's going to take longer to finish it. So there are 2 independent variables and each variable has 3 levels. So that would mean this is a 3 by 3 research design. If we multiply 3 by 3, we get a product of 9, which would mean that this particular design has 9 possible conditions or 9 possible levels. So this type of design gives us 2 pieces of information. The first one is what is the effect of each independent variable alone on the dependent variable? For example, is only the size of the portion affecting whether the dog chews or swallows? Or is only the type of food going to affect whether the dog chews or swallows, right? So we can pull apart the individual independent variable effects. But the second thing we can find is what is the effect of both independent variables combined? Which means, is there a particular combination between the size of the portion and the type of food? Again, remember, there are 9 possible combinations. That means I can pair a small portion with wet food, a small portion with dry food, and a small portion with mixed food. I can also pair a medium portion with wet food, a medium portion with dry food, and a medium portion with mixed food. And the last 3 would be a large portion with wet food, a large portion with dry food, and a large portion with mixed food. So there are 9 possible conditions, 9 possible combinations that could actually make the dog chew her food and not swallow it. So basically these combined effects, right? Maybe there's one particular combination that will be driving the effect, while the independent variables alone can't show us that effect. So what are the type of tests we use for factorial designs? Well, the first one is a t-test. In a t-test, we compare the averages or the means across both groups of levels of the independent variable. The proper analysis for 2 levels within one independent variable would be the t-test. But in this situation, we have 2 independent variables. So if 2 independent variables each have 2 levels, that gives us 4 groups that we're comparing. In this specific example, we had 1 independent variable with 3 levels and another independent variable with 3 levels. So that already gives us more than the 2 levels that an ANOVA should be used to test. That already gives us more levels than a t-test should be used for. So what do we use in that case is an ANOVA. An ANOVA stands for analysis of variance. An ANOVA, instead of measuring the averages, it is now going to take into consideration the variance of the groups. An ANOVA is the proper analysis for more than 2 levels within an independent variable. And so the reason behind this is basically to reduce the error, to reduce inflation of error. If you think back to hypothesis testing and your 7 steps, you should remember that we accept by default 5% error. So if we're accepting a 5% chance of being wrong, it means that we're accepting 95% chances of being right. We typically don't allow for larger rates of error, but we could decrease the error. So sometimes error could be 5%, 2%, or even 1%. However, if you have 2 independent variables and each variable has more than 2 levels, or even if they only have 2 levels, right? That's already a comparison of 4 groups. A t-test gives you a comparison of 2 groups at a time. Now imagine if you compared the first 2 groups and at a 5% error level, and then you compared the other 2 groups also at a 5% error level, all within the same research question, all within the same analysis. Now your error has increased to 10%. Imagine that you have an independent variable with 3 levels, right? That means that there's 3 possible combinations. And so you have comparison of group 1 and group 2, that's 5% error level. You have comparison of group 2 and group 3, another 5% error. And then you have the last comparison of group 1 and group 3. That's 15% error, which again is not acceptable. So instead of doing multiple t-tests when you have multiple levels of your variables, you would use something like an ANOVA. So this leads us directly into our discussion of main effects versus interactions. A main effect basically tells us whether each independent variable alone has an effect on the dependent variable. Does the size of the portion only affect the dog's eating behavior, or does the type of the food only affect the dog's eating behavior? An interaction effect would show us a combination of those 2 independent variables. So do both of the IVs combined have an effect on the dependent variable? You can have as many interaction effects as you have independent and dependent variables. So the question becomes, does the size of the portion and the type of food affect the dog's eating behavior? So the question I ask you is it possible to have main effects without an interaction? Is it possible that only the size of the food alone will keep her from swallowing the food? And is it possible that only the type of food will keep the dog from swallowing the food? Hopefully, in your head, you thought that the answer is yes. It's absolutely possible to have main effects without an interaction. Okay, is it possible to have an interaction without main effects? Meaning, is it possible that the type of food alone and the size of the portion alone don't have effects, but when you combine a specific type of portion with a specific type of food, then the dog actually stops swallowing the food and starts to chew? So absolutely, you could totally have an interaction effect without main effects. So the answer to both of these questions would be yes. It is possible to have a main effect without an interaction, and it is possible to have an interaction without main effects. So now let's talk about non-manipulated variables. Okay, so some factorial designs include both experimental and non-experimental variables. The variables that we as researchers cannot manipulate or change or assign, those are called non-experimental variables. These are things like a person's age, gender, ethnicity, personality type, clinical diagnosis, etc. All of these things that are related to the individual characteristics of participants, those are things that you as a researcher cannot control. And oftentimes when we conduct research projects, our questions revolve around a difference in gender, a difference in age, a difference in personality type. And so basically what this tells us is that our design cannot be truly 100% experimental if we are using any type of non-manipulated variable as an independent variable for our study. So anytime you want to test the effects of gender on academic achievement, effects of gender on depression, because you cannot control the gender variable, right, it becomes a quasi-experimental study because you are using a non-manipulated variable as your independent variable, right, as the stimuli for your study. So remember, true experimental design also has to use random assignment of non-manipulated variables. Another word for non-manipulated variable is a subject variable or an attribute variable. So let's think of an example of a factorial design that uses subject variables. So let's imagine that I was interested in measuring the motivation of two different age groups to watch a particular television show. So one of the shows was a thriller and one of the shows was a comedy. So I'm interested to measure motivation to watch a program based on the genre and the age of the participants. Which of these would be a non-manipulated variable? If you're thinking to yourself, the age, then you're absolutely right. I, as a researcher, cannot force someone to be of a certain age. So that is the non-manipulated variable. But as the researcher, I can control which genre of show I am showing to the participants. So this is a factorial design because I have two independent variables, and one of them is a non-manipulated variable, which in this case is age. Anytime you add gender to a factorial design, right? Anytime gender, you're looking for differences between male, female, non-binary, etc., then it becomes a non-manipulated variable and it becomes quasi-experimental. But I do want you to understand, if you are collecting demographic information on the gender of participants, but you are not using gender, you are not using age, you are not using ethnicity as a main independent variable to show an effect in your dependent variable, then that has absolutely nothing to do with whether your experiment is truly experimental or not. Remember, non-manipulated variables are important to the truthfulness of your experiment only if you're considering them as a key way to differentiate between the differences that you see in your dependent variable. So demographic information that you collect doesn't make your experiment quasi-experimental. It's only if you're using it to look for differences in the dependent variable. So now let's talk about assignments of participants in factorial design. Previously, we learned about independent groups design and we talked about within groups design, right? We have between subjects and within subjects. So for independent group designs, that's when different participants are assigned to different conditions of the study. Repeated measures is when the same individuals participate in all conditions of the study. So what happens if you have a combination of the two? Well, that means that you have a mixed factorial design. Mixed factorial designs use combined assignment. It uses both independent and repeated measures group design. So for example, let's say I'm interested in measuring the temperament of a certain group of students based on two variables. The first variable would be weather. I'm interested in comparing students' temperament on sunny versus rainy days. Okay, so weather is my first independent variable. My second independent variable would be the type of teacher the students have. So for example, on Monday and Wednesday, they will be in Jennifer's class, and on Tuesday and Thursday, they will be in Diana's class. Because the students who attend class on Monday and Wednesday are the same people, that gives me the repeated measures assignment. And similarly, the students in Diana's class are going to be the same on Tuesday and Thursday. So that is also a repeated measures assignment, right? Because it's the same people. However, what the differences that I'm going to look at is how they felt on a sunny day versus a rainy day. So because the weather conditions could be different across the two classes, that would be my independent group assignment. It's also entirely possible that maybe Monday in Jennifer's class it was sunny, but Wednesday in Jennifer's class it was rainy. So I would also be comparing groups within the same class across the two different weather conditions, right? So in a mixed factorial design, it's totally possible to have both independent groups and repeated measures assignment of participants. And here's another example. On the left-hand side, we see duration, right? The amount of time, the length of therapy. So on the top, we have 2 weeks, and below that, we have 2 months. Across the top, we have the different type of psychotherapy. The first one being cognitive, and the second one being behavioral. So we have so far 2 independent variables. We have the duration of therapy, and we have the therapy type. If you look inside the boxes, we also have therapists, and the therapist could be either female or male in all of the situations. So now we have a third variable. In this case, it is a non-manipulated variable, but we have a third variable with 2 levels. So time, the length of the therapy has 2 levels, psychotherapy type has 2 levels, and therapist gender has 2 levels. So this would be a 2 by 2 by 2 factorial design. So if we think about this, right, we do have independent group design because we have people who are in the cognitive therapy are different from the people in the behavioral therapy. So across the therapy type, those are going to be between groups, between subjects, right? Independent group measurements. However, within each type of therapy, we have 2 different durations of time. We're comparing their behavior 2 weeks into therapy and then 2 months into therapy. But the people who are in the cognitive condition at 2 weeks are going to be the same people we measure in the cognitive condition at 2 months. And similarly, the group of people in the behavioral condition at 2 weeks are the same people that we're going to measure and compare to the behavioral group at 2 months. So the duration of time within each type of psychotherapy gives us the within group assignment, right? The repeated measures, because we're comparing the same group of people to themselves more than once. Lastly, we have whether the therapist is male or female, which will also give us a between group measure because we are comparing across 2 different gender types. So you can see that the sky is honestly the limit with the number of variables that you implement and the number of factors that you're looking for differences among. However, things like factorial designs, especially mixed factorial designs, tend to get a little bit messy if you add too many variables. But please know that it's totally possible to use a combination of independent group and repeated measures assignment when it comes to mixed factorial design. As always, thank you very much for watching, and I will see you next time on Research Done Right.